So welcome back to this Excel sheet where we are going to calculate the max power of the motor for acceleration requirement. But by the way, what is the acceleration requirement? Come to this vehicle input sheet and let's see what we have defined it. So we want to go from 0 to 60 kmph in 8 seconds, and we want to calculate what is the motor power which can enable me to go from 0 to 60 kmph in 8 seconds. And we are going to calculate that motor power using smart method. What is that smart method? We will start with the constant torque, and then we will keep going till intermediate speed, and then after we will switch to the constant power mode, and we are going to cover rest of the speed. Now, there could have been a magical formula to calculate this max power or the constant power that we're talking about, but there is no direct formula, and hence we need to rely on iterative method. What is that method? We will assume the constant power and we will calculate the time, and if the time is not matching with the defined time, then we can increase and decrease the power in order to match that. So here if you see in the first cell, I have assumed initial value or the seed value of the motor power is 30 kilowatt. Why 30 kilowatt? So to reason behind this, just come here, fun with the vehicle dynamic. So for the rated mode, if you see, the power is 27 kilowatt, and in all practical case the power for acceleration will be higher than this rated mode, and hence because of this I have taken the value which is more than 27. You can define any value which is 35, 40, but I have kept 30 as the initial value. The next, I have defined the slope of the road which is 0, all the acceleration performance done on the flat road, and here I have defined the max torque of the motor which is 94.47, which I got it from here, the peak torque requirement. And the next, from here to here, I am calculating all the constant which is required to calculate the time using constant torque method and the constant power method. For constant torque method, I need the constant B. I am calculating this B using this formula, and for the constant power method, I need the constant which is C, D and A using this formula, as you can see here. And the next, I have defined the number of steps. So in constant power mode, in order to calculate the time, we have to give the number of steps. Remember, we were calculating the time using area under the curve, and that's where we have to define the number of steps, and that's where I have taken here 100. You can take any values here, 100, 500, 1000, you can take it. So now let's come to this region here. So the first column, which is the speed of the vehicle, so I have gone from 0 to 60 kmph at the step of 1 here. You can take any step, 0.5 or 0.25, but I have taken the step of 1. So at the start the time will be 0, and here I am just converting this kmph to meter per second, and I am here. If I know the speed of the vehicle, I can calculate the motor RPM, and that's what I have used this formula to calculate the motor RPM. And here I am starting with the max torque which is 94.47. And how to calculate the power? Power will be just the multiplication of motor speed in radian per second and the motor torque in Newton meter. So that's what I have written the formula for the power here. So what I am doing here I am calculating the time using constant torque method. So let's say I came from 0 kmph to 1 kmph using constant torque method. What will be the time? So I calculated the time using this formula. And also I'm calculating the power here because I know the vehicle speed, I know the motor RPM, and I already know I'm going with the constant torque. I can calculate the power. So I will here implement some logic here. So let's say if power is less than this assumed value, keep calculating the time using constant torque method, else switch to constant power method. So if you come here, you can see here, if power is less than the assumed value, calculate the time using this formula, else calculate the time using this formula. And inside this Excel sheet, I have written one function to calculate the time in using constant power method. So let's say you want to go from V1 to V2 in a constant power mode, then what you have to do, just you have to write this formula int. So you will get this pop-up. So this is not the Excel formula, I have written this formula in form of macros code here. So here you have to supply V1, V2, number of steps, which is you can take it here, and then the constant ADC. And if you do that, then you will able to get the time that is required to go from V1 to V2 in constant power mode. So if you come here, so that's what here I am calculating the time in constant power mode. So once again, I am calculating the time using some logic. What is that logic? If power is less than this assumed value, keep calculating time using this formula, which is constant torque method. If power exceed this value, switch to the constant power mode and calculate the time using this formula. So that is simple logic that I am using, and you just drag this blue region till here. So that's what I have done it. So if you come to this, at the end of 60 kmph, the time is 9 seconds. But before that, just come here. So it went till here using constant torque method, and then after it switched to constant power method, because here the criteria has met, and then after it started calculating time using constant power method. And at the last, when you come here, so the total time it took 9.04 second. But how much we need? We need only 8 second. So we need to increase the power. So let's go ahead and then increase to 32. And if you come here, now we got 8.66.